Today's discussion and lecture will come from Section 1-4, Direct Variation and Proportions. You can see our learning goal for today will be some new material and some review. Starting with a direct variation. This is the new piece, and we have y equals kx to the n, where k cannot be 0, and n has to be a number greater than 0. If we stick with the chapter discussion, which has been all basic linear equations, then we want to focus on the equation y equals kx to the first, and we usually write that as just y equals kx. We read it as variables and numbers, symbols only, and that would be just like I have, y equals kx. If we want to read it for meaning and put the English behind it, we would say y varies directly as x to the first in this case, or y is directly proportional to x to the first. You'll notice that when you read this, we're not saying anything about the k value. And the k is never mentioned in the reading of the equation, but k is called the constant of the variation. This is only one of many types of variations. There's relationships about the x and y values in all the types, and they're all different. So this one, called direct variation, y equals kx. It looks very similar to our y equals mx plus b equation, but the b is missing. So first question is going to be just with these three equations, which of them is a direct variation equation and which of them is linear? Because linear meant it was to the power of 1, where all our direct variation equations do not need to be to the power of 1. And then second question, how do you read each of the following? Read them for meaning. I'm going to read them by symbol form first here, and we'll help discuss the direct variation equation. Y equals 2x squared. M equals n to the 4th. C equals 1/2 d. So right away when I look at those, I'm saying, do they fit the pattern y equals kx to the n? If they do, it is a direct variation equation. And then to go one step further, if they fit y equals kx to the first, then they would also be linear. So looking at our three, I believe y equals 2x squared would be a direct variation equation, however, it would not be linear. M equals n to the 4th would be a direct variation equation. Again, it would not be linear. Now some of you are going to say, well, it doesn't have an x and a y in it. It doesn't need to have an x and a y in it. The m and the different variables, m and n in this case, can be substituted interchangeably for x and y, and you should know that from your Algebra 1. Last equation, c equals 1/2 d. Again, it does not have the x and y in it, but it does fit the pattern, basically where k is 1/2 and the exponent on the d is 1. So of the three here, they are all direct variation equations. The last one is the only one that's linear. And then as we go through them now, how would you read them for meaning? Not just using the x and y's, how would you read it for meaning? So the first one, y equals 2x squared. Reading the numbers and symbols. Reading it for meaning would be y is directly proportional to x squared. If you didn't say that, you could have also said y varies directly as x squared. Second one, n varies directly as n to the fourth power. You could have also said n is directly proportional to the fourth power of n. Another way to say it. You have a couple choices. And the last one, c varies directly to d. You could have said c is directly proportional to d, would be correct. Now, why are we going over how they're read? Because most of these problems you are not going to be given an equation, you're going to be given words. The words will dictate what you will transpose into numbers and symbols. So an example of that is where we will head next. If we gave you y varies directly as x, write an equation that relates x and y, and then find the value of y when x is -2. Sounds like you have several things going on there. So let's start. Y varies directly as x is your clue to how you write your equation. Your step one is writing the equation. Step one. Then, second part, find the value of y when x is -2 would come later. So given the variables x equals 2, y equals 8, we would be using those to write our equation. So here is, and you can use and stop and pause this if you need to write some notes. Here are the basic steps you would use. Y equals kx to the n is our direct variation equation, so we put that in. It's said directly, and it's the general form. It also did not say anything about to the second power, to the fourth power, squared, or anything like that, so you know and have to assume that the n value is 1. So you will substitute an x value of 2, a y value of 8, and an n value of 1. That leaves only the k to be determined. So in doing so, you could now solve for k by dividing both sides by 2. That gives you a k value of 4. That could now be substituted into the original equation, and you would have your generic or basic setup of this situation's direct variation equation. From there, you could do step 2 or part 2, find the value of y when x is -2 by substituting a -2 in for x and doing the math to give us the y value of -8. So let's try one together using that same setup. So pretty similar, different numbers chosen. So think about what you were supposed to do, and we will go through those steps together here. So step 1, y varies directly as x. So most people write down the generic equation that sentence indicates. So y equals kx. Again, we do not say x to the second, x to the third, because there was nothing in the problem that indicates it's to a power. So you have to assume it's to the first power. Now, write an equation that relates x and y. So your very next step will be take the given x and y values. So y is 2 when x is 12. And we should be able to solve by dividing by 12. We come up with k equals, we reduce, we get a k value of 1/6 this time. So we write our original equation again, y equals, with our k value substituted in, 1/6 x. From there, we should be able to do the second part of the equation, which is then find the value of y when x is -2. So if we said y equals our 1/6, because the k value doesn't change, and our k value is now -2, and I'm going to put it over 1 just because we have fractions involved. Do the math and do the canceling. We should get a y value of, positive times a negative is a negative 1/3. So when x was -2, y was -1/3. And you saw the relationship of x and y on the last problem as well. As you put more and more values in, you should continue to notice x and y relationships. So, in summary, we have 3 steps that basically follow every single time we do a direct variation equation. Step 1, find the constant of the variation. That's finding the k value. Put in the given x and y to help you find k. Step 2, rewrite the formula using that constant. So once you find the k value, you can rewrite and put that k value back into the original equation. That's the equation you would use for all other questions pertaining to this problem. Step 3, evaluate the formula for the given value. Whatever follow-up questions they ask, that's what you would be plugging in and solving to get your final answer. Now, as you notice some of these x and y combinations, you should be noticing that in every single one of these direct variation equations, if you look at all the x and y's you put in for a specific equation, as x goes up, y is also going up. This is a characteristic that's particularly important for direct variation equations. Now, once we have direct variation equations, we have a property that involves all of them. So let's assume in this one that x1 and x2 cannot be equal to 0. And if we look, we have x1, y1 are points, as well as x2, y2 are points. So basically, if we have 2 points, and they satisfy our equation, that equation is our direct variation linear equation, y equals kx, then we can also say that each of those ordered pairs, if you put them in a ratio of y1 is to x1 and y2 is to x2, that should give you your hint or indication of what your k value in your direct variation equation is going to be. It is a relationship very similar to your slope of a line. It relates to your change in y over your change in x. It relates to your rise over run that you learned in Algebra 1. And in doing that, we should also review how we solved proportions in Algebra 1. A proportion is a statement that 2 ratios are equal. A ratio is the comparison of 2 quantities by division. So if we look at this statement, A is to B equals C is to D. Some people will say it looks like fractions. Well, fractions are ratios. So right now we're looking at A over B as a ratio and C over D as a ratio. The whole entire equation is our proportion. To solve these, most of us learned that we would do the cross products. A times D has to equal B times C. Some of you have also learned that the product of the means equals the product of the extremes. That came from the older style use of proportions, but it came from specifically the different styles or ways we wrote ratios. So if you go back into your previous knowledge and say, hey, I can write a ratio like A is to B as a fraction. I could write it with a colon, A is to B, or I could write A to B with the word 2 in between. Those are all ways to write a ratio. But the olden way, the colon method was most popular. Now we tend to use the fraction form a little more. So where did this means and extremes come from? If we wrote this same proportion, A is to D as B is to C, In colon form, it would be A colon B equals C colon D. And if you compare and look at the middle terms of that proportion, those are the means. Means meaning finding the middle. Versus if you looked at the outside terms or the extremes of that proportion, you would get the A and the D. So that's where that phrase comes from. The product of the means equals the product of the extremes. You should remember solving these from algebra, but just real quick as a review, for example, on the fraction 1/2, we also know the fraction 3/6 is equivalent to 1/2, but if we did means and extremes to solve that, we would get 1 times 6, which is 6, has to equal 2 times 3, which is 6, and in a proportion, the means and extremes have to be equivalent. One thing you are going to see is that if we give you an unknown, let's say x is to 5 as 3 is to, let's make it 8, we'll get means and extremes, 8x equals 15. And from there, divide by 8, and you will have your x value of 15/8 as your solution. Not all x and y values in means and extremes are going to be whole numbers, so keep that in mind. All right, we should be able to move forward here. Any other examples that you feel are needed, come to class with questions on, and you should be able to do the work from the section 1-4.